Today we will learn Cartesian representation of vectors. Now what is Cartesian representation? So we are already familiar with Cartesian coordinate system. What is a Cartesian coordinate system? So in the Cartesian coordinate system we have two axes. We have x-axis and we have y-axis. Okay, and if you take any point here, then it has two coordinates. Okay, these coordinates are x comma y. Okay, if you take Cartesian coordinate system in 3 dimensions, then it has 3 coordinates. So in 3 coordinate system, this can become x coordinate, this can become y coordinate, and this can become z coordinates. Okay, so these are the 3 coordinate systems. If you take a point over here, then this point has 3 coordinates, any point. Okay, it can have an x coordinate, it can have a y coordinate, it can have a z coordinate. So we will learn about 3 simultaneously, about both. Okay, first I can have a vector which can be drawn from origin to the point. Okay, I can have a vector. So what we do is, let us first focus on the two-dimensional. I will take only x-axis and y-axis, and we will focus only on 2 dimensions. Okay, so this is your x-axis, this is your y-axis. Okay, now in order to have a vector, we need to have some vectors which gives direction to the vectors, which gives direction. So you know, such vectors are called unit vectors. In the last class we have understood unit vectors. So we can define 2 unit vectors here. Okay, we will need 2 unit vectors. What are those 2 unit vectors? One unit vector we will need in the x-axis direction. So let us define a unit vector in this direction, in the x-axis. So along the x-axis we will have one unit vector. Let us call this unit vector as I cap. Okay, we will call this unit vector as I cap. So along the x-axis we will define a unit vector called I cap. It is nothing but a vector, unit vector along x-axis. Okay, it's a standard unit vector. Whenever we will need a direction along the x-axis, we will use this. Okay, what will be the magnitude of I cap? Can you tell me? What will be the magnitude of I cap?
This sample.
No, but how much it is? How much is this from here to here?
X minus I cap.
No, it's written, no? It's a unit. So the magnitude is 1. So whatever is 1 here, up till here on the x-axis is 1. Okay, then here will be 2, here will be 3, so on and so forth. Is that clear? Okay, now we will look at y-axis. How can I define a unit vector on the y-axis? So I can take a similar unit vector on the y-axis, and I will call this as j cap, small j. Okay, so along the y-axis I would say that j cap is the unit vector along y-axis. J cap is the unit vector along the y-axis. What does it mean? What is the magnitude of j cap? Remember, it's a unit vector. Any vector with a cap, is has the magnitude 1. Okay, that means from here to here the length is 1, and you go from another same distance, this is 2, this is 3 unit, so on and so forth. Okay, fine. Now suppose we have a point here which has a coordinate x comma y. Is that clear? Now if I drop a perpendicular on the x-axis and it will intersect the x-axis at this point, then if this point has a coordinate x comma y, then obviously this point has coordinate x, correct? Now I have a magnitude x. Now can I design a vector in this direction, in the direction of x? Can I design a vector in the direction of along the x-axis up till x? So how do I design this vector, green vector? This can be designed very easily. I have a magnitude x, and I can multiply this with I cap. Okay, or let us understand it in more detail. Example, a vector whose length is 2 unit. I want to design a vector whose length is 2 unit along the x-axis. How do I write? From the origin. How do I write this vector? So its length is 2 unit and it is along the x-axis. This 2 is a magnitude, remember this. This is a magnitude. What I want to do is convert it into a vector. How do I convert it into a vector? I assign the direction. Who will assign the direction of x-axis? Remember, this is along the x-axis. So x-axis की तरफ direction assign कौन कर रहा है? Unit vector, I cap. I cap assigns the direction. So how do I get a vector with length 2 now? So 2 into I cap. If I multiply the direction giving vector, this is direction part and this is the magnitude part. I multiply the 2 and I will get a vector which is called as 2 times I cap. You understand that? I will get a vector which is called as 2 times I cap. What will be this vector? This vector is starting here and ending here. Okay, this vector is my 2 times I cap. Suppose I want a vector which is of the length 3, say till here, from origin all the way till 3. I want a vector till here. Okay, how do I get such a vector from the origin till 3?
3 into I cap.
Yes, so magnitude part you can see is 3 and I want it along the positive x-axis, so I will multiply by I cap. Okay, so if I multiply by I cap, I will get 3 times I cap. Okay, remember this I cap, j cap is, I have right now shown is towards the positive side. If you have to show it on the negative side, they will become minus I cap, minus j cap. Okay, I'll show it in a while. Now this is 3 I cap. 3 I cap. So if I want a vector, suppose which is of the length x. Let me remove all these other vectors. I want a vector which is of the length x. X means I want a vector whose length is starting from the origin, goes all the way till x here. I want a long vector. So what will be how do I represent the vector now?
X into I cap.
So x into I
I
cap, which I can now write it as x
times I cap.
I times I cap. Okay, so this is one vector. Similarly, along the j axis, suppose if I have to get a vector of length 2 along the y axis, then what will be this vector called as?
2 times j cap.
This will be called as 2 times j cap. If I want a vector of length 3, 1 minute. If I want a vector of length 3, then it will be called as 3 times j cap. If I want a length, suppose I drop a perpendicular, so that this coordinate is y, and suppose I want a vector of length y from the origin. Okay, then what will be the?
Y times j cap.
It will be y times j cap. That is y j cap. Correct? So now let us rewrite it in a very neat and clean manner. So I draw the two coordinates. This is x coordinate, this is y coordinate. My point, let me call that point as A. It has coordinate x comma y. Okay, if I drop a perpendicular here, then the coordinate from the origin to this x, I can always draw a vector which we have just seen. So this vector can now be written as, what we can call this vector as? We can call this vector as x times I cap. Okay. Similarly, if I drop a perpendicular, from the y-axis or on the y-axis from the point A x comma y, then I can always draw a vector from the origin to this point. Okay, this vector would be y times j cap. Okay, understood? Now this vector can be translated, moved on this side. Remember, a vector can always be translated. That means without changing the direction, without changing the magnitude. So you can move this. So this vector which is on the right side of this rectangle is also y times j cap, isn't it? So similarly, I can even translate x times I cap. So on the top I can always write x times I cap. Okay, but then right now I don't need it, so I delete this one. Okay, but what I need is this on to right side. Now let us draw a resultant vector. You can now see that these are the two vectors. You starting from here, there is one vector on this side, and on the head of this there is tail of another vector, correct? So it's a triangle law situation. we have two vectors. One is xi cap. On the head of this, we have another vector which is y times j cap. So that means these two vectors are put in a triangle law formation. Correct? So where will be the sum vector?
x I into I cap का tail से
Yes, the sum vector will be from the tail of
j cap
xi cap to the head of yj cap. So this is going to be the resultant vector. Okay. So let us call this resultant vector, since it is from the origin to A. We can give names like vector OA. Okay. This is one possible name. Other possible name is we can simply call it vector A. Okay. So OA or A. So we can give two names. So let us call this vector OA or vector A, which is a resultant vector, isn't it? So this resultant vector can be written as sum of the two vectors. Which are the two vectors? X I cap plus y j cap. Okay. So this is how you represent a vector in Cartesian coordinate system. Okay. We have a vector a cap, which can now be written as x I cap plus y j cap. So this is how you represent a vector in two-dimensional, we call it two-dimensional coordinate system. Okay, it is in a two-dimensional coordinate system. Here the coordinate x is called as x component. Remember, we are now introducing a new word. It is called component. It is called x component of vector A. The x is called as x component of vector A, and small y is called as y component of vector A. Is that clear? Now suppose, how will you get the magnitude of A in this case? This is the vector representation. How do we get magnitude of A? So you can now see getting magnitude of A is very easy. This is 90 degree, and you can see that this triangle is a right angled triangle. Okay, this is shaded triangle is a right angled triangle. So you can always apply Pythagoras theorem. So its x bottom side has the length x. Okay, and the right side has the length y. Okay, and hypotenuse I can say it has the length a. So I can write Pythagoras theorem: a square is equal to x square plus y square. Understood? So what is a then? A will be equal to root of x square plus y square. Okay, so this will give you, if you know x and y, then this will give you the magnitude of x. You can get this magnitude from the parallelogram law of vector addition. What was parallelogram law of vector addition? Vector r is root of p square plus q square plus 2 pq cos theta. Now here what are p and q? Remember, p is x, so it is x square. Q is y, so it is y square. This is 2xy cos z cos, and Angle between the two vectors is 90. So cos 90. Okay. But what is cos 90? Cos 90 is 0.
0.
So this term becomes 0. So what is left with? R is root of x square plus
I square.
y square. So this, which is nothing but your a. So this gives you the magnitude. So let us now revise the basic idea that we have learnt. Okay. So we have learnt first, we have revised Cartesian coordinate system in 2 dimensions. We are right now talking about 2D. So we have x-axis, we have y-axis, we can have a point which can be called as A, and it has coordinate x and y. If it has coordinate x and y, what it means? It means that if you drop a perpendicular, then on x-axis it will cut at x, and on y-axis if you drop a perpendicular, and it will intersect the y-axis at point y, while this is origin. Okay, this is a 3-dimensional coordinate system that we will learn later. Then we have learned the concept of unit vectors. So we defined 2 unit vectors, I cap along the x-axis and y j cap along the y-axis. What we have shown is their magnitude is always 1. So उनका काम क्या होता है? वो सिर्फ डायरेक्शन देते हैं, वो मल्टीप्लाई होंगे and they will give the direction. So their length is one length, 1 unit. But suppose if you want a vector of length 2 unit, then you multiply 2 to I cap. So you get 2 I cap. You get a vector of length 2. This is nothing but vector of length 2 along positive x axis. Okay. Similarly, this is, if you multiply by 3, you get a vector of length whose length is 3 along the positive x axis. So if you want a vector whose length is x, how do you get it? Very simple.
X I cap.
You multiply x to the I cap, you get x I cap. Okay. Similarly, if you want a vector of length y along the y axis, then you multiply by j cap, y j cap. Okay. Then we have now understood from these 2 vectors, you can see that they form a rectangle. This, you can see that you have x, you have y, these are the perpendicular sides, and the right side is also y j cap. So this becomes a rectangle. That is why these are called rectangular components. These x and y are also called as rectangular components. Okay, so you can have the vector along the x-axis called as x I cap. You can have a vector along y-axis, you can call it as y j cap. The sum of the two, remember, they are kept in a triangle law formation. On the head of x, we are keeping tail of y j cap. So you can add them and you get the resultant, that is the diagonal vector. So this is the 2-dimensional representation of a vector. Okay, this is 2-dimensional representation of the vector. How do we get magnitude of the vector A? You get a square is equal to, you can see that it's the triangle given over here is shaded triangle, is a right angle triangle. So you can apply Pythagoras theorem, and that will give you the magnitude of A, root of x square plus y square. This you can obtain from the parallelogram law also. Okay, so we can stop this lecture over here. In the next lecture, we will understand more about the Cartesian coordinate system.